So here we are going to start with the weighted mean. That is the last part of the mean that we are working on. Let's start with the example. So in this example, they say Marisha completed her first semester at Community College of Aurora, and her result is shown below. We have to determine GPA, the grade point average. So here you have the subjects: statistics, sociology, psychology, computer programming, and drama. And then the grades are given here, A, B, A, C, A. And then the credit hours are given, 4, 3, 3, 5, 1. So we need to find the GPA, and always remember GPA is the weighted mean. Okay, so GPA is the weighted mean. And what was the formula for the weighted mean you copied? I think it was W equal to sum of X times W divided by sum of W. W is the weight. So the credit hour is your W. Credit hour is W. And the grade is your X. And the way we give the grade is a little different here. For A, we say GPA 4. So we start like this. A is 4. B is 3. C is 2. D is 1. And F is 0. Always remember this. Okay, you can write this for you for reference, or you can refer back to the video later on. Then you'll see that A is 4, B is 3, C is 2, D is 1, and F is 0. So here you can see statistics A, meaning of that is 4. And then sociology is B, that is 3. Psychology is A, so that is 4. Computer programming is C, and that is 2. And then drama is A, which is 4. You can see there are so many A. A is 4, which is in statistics. And then you have A in psychology and A in drama. But there is a C here in computer programming, and this is a 5-credit class. And this will definitely lower the GPA, let's say. Although there are 3 A's, your GPA will not be close to 4. Let's find it out. So in order to find the GPA, we need X times W. So we have X, we have W. So I need next column where we need to find X times W. So let's do that together. X times W. X times W in next column. So we multiply X and W. So first one is 4 times 4. How much is 4 times 4? You can unmute and speak. That's 16, right?
16.
3 times 3, 9. How much is 4 times 3?
12.
12. 2 times 5?
10.
10. And then 4 times 1?
4.
Is 4. Okay. And then down here, we are going to find the total. Let's see what total we need. If you look at the formula, we need the total of X times W. So here you have X times W. We need the total of these. So please grab your calculator and add those values. That is 16 plus 9 plus 12 plus 10 plus 4. How much is that? Is it 51? I got 51. And add these values now. W, sum of W, 4 plus 3, 7 plus 3, 10 plus 5, 15 plus 1, 16. Is that right?
Yes.
16 credit class. And the total X times W is 51. Make sure you check this whether that is 51 or not, okay? Now let's find the weighted mean, or GPA. Now GPA is the weighted mean, which is given by the formula sum of X times W divided by sum of W. So this implies your GPA is equal to sum of X times W is 51 divided by 16. And I told you this will not be close to 4 because in 5-credit class, C got C. So let's divide that. How much is 51 divided by 16? 3.1875. Okay, 3.1875. So you can see that, as I told you before, because there are a lot of A, it doesn't mean that your GPA will be close to 4. In a 5-credit class, this is so many credits. In a 5-credit class, her grade is C, which drops the GPA. And you can see the GPA is now close to 3, not close to 4, right? So this is pretty much a B, not exactly B. It's still, uh, you know, the B, but it's a lower B, not the higher B. That's what I meant to say. So it's close to 3. It's a lower B, not a higher B. So you can see that if you get lower grade on a 5-credit class, your score will be less. So be careful with your number of credits when you're taking any class. If in this drama class she obtained a C, maybe she will still be close to 4. Okay. Any question in this one before we move on? Just say yes or no, then we'll go to next problem.
No, sir.
No. Okay. Now we are done with mean, the first central measure of central tendency. We look at calculation of mean using various techniques. That's for the ungrouped data, group data, and the weighted mean. Now we are in next type of measure of central tendency. It is called the median. And when you look at the definition of median, you'll see that the median is the midpoint of the data arrayed. So if a large set of data is given to you, first what you're going to do is you're going to arrange the data from smallest value to the largest value, and you look at the value in the middle. That is called the median. And the symbol for the median is MD. That is the symbol for the median. MD is the symbol for the median. Like for the mean, we use X bar. For the median, we use MD. Here are the steps for you to calculate the median. I think it's better if you copy this, if you have not printed the note catcher. The first thing is you arrange the data in ascending order. Okay, that is from the smallest value to the largest value. Then determine the number of values in the data. How many values are there? So first step is to arrange the data from smallest to largest. Second step is to see how many observations are there. That is, you have to find the number of observations are n. And then the third step, if n is odd, so there are two cases. When you find how many observations are there, n can be odd or n can be even. If it is odd, select the middle data value, and that is the median. So the middle value is the median in that. But if it is even, what you have to do is you have to find the two middle values and find their average. So if it is even, it is the average of two middle values. It's the average of two middle values. Okay, so those are the steps that we use in calculating the median. When you just look at the step and when you just look at the definition, it may or may not make sense. But when you go to example, this will definitely make sense. So we are going to start with the example. Okay, here is my first data set. And the first example, for the following set of data, we have to find the median. So here we have the observation. Let's read these numbers. We have 1, then we have 11.5, 6, 7.2, 4, 8, 9, 10, 6.8, 8.3, 2, 2, 10. Make sure you read these numbers properly because there are comma and then that point. Sometimes a student get confused with these things. So the first is 1, then we have 11.5, 6, 7.2, 4, 8, 9, 10, 6.8, 8.3, 2, 2, 10. So these are the data values that we have. And you can see that these data values are not arranged. They are not arranged from smallest number to the highest number. So what you have to do is we have to arrange this number. Okay? We need to arrange this number. So if I ask you to arrange the number, what you will put first? Look at these values and tell me what you will put first.
1,
1.
Then what you will put next?
2,
How many twos?
2 of them,
2 of them. Okay. And then there is no 3. Then you'll go to
4,
4 and so on, right? You can arrange this data just by looking at it because you have a small set of observations given. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I gave you 13 of them. So you can just look at it and you can arrange. I know that you can do that. But if I give you so many observations, say I gave you 20 or 25 observations, then it will be a little difficult to arrange the data just by looking at it. You can do it, but it will take time, right?
Right.
Okay, so what we are going to do now is we are going to learn how to arrange this data using calculator so that you'll not make any mistake and you'll have a perfect result. So I'm going to share my calculator now. Okay, can you see my shared calculator? Yes,
Yes.
no? Okay. So I'm in the main screen now. I'm going to enter the data. So what you have to do is make sure you follow along with me. Go to stat and the number 1, which says edit, and enter. So the list will appear. If this list is not clear, you have to clear this. So in order to clear, you have to go to list 1 or list 2 or list 3. Highlight just like that and then clear and enter. Everything will be cleared. Now here we are going to enter that data from the example. So please enter along with me. The first value was 1. The second was 11.5. Okay. Third is 6. Next we have 7.2. If I'm not doing it right, just tell me. Then we have 4. Then we have 8. Then we have 9. Then we have 10. Then we have 6.8. Are we doing it right?
Yes.
0.8. Then we have 8.3. 8.3. Then we have 2. Another 2 and 10. So you can see that we entered 13th of the 13 data point and we counted there were 13. Now it says L1 14. Now I'm in 14th row. That is the meaning of that. So we already entered 13 data. Now we need to arrange this data. Okay, we need to arrange the data. So in order to arrange the data, just give me a second. Let me find that first because I kind of forget. Okay, in order to arrange that data, go to stat. And then here in number 2, it says sort in ascending order. That is the meaning of that. So go to number 2 and hit that number 2. It says sort in ascending order. But what do you want to sort in ascending order? The data which we entered in L1. So here where it is blinking, here you'll type L1 by pressing 2nd and 1. And then close that parenthesis, which is here, and enter. Now it says done. Meaning of that is if you go to list 1 now, okay, if you go to list 1 now, you'll see that your data is arranged. We kind of arranged that manually before. We say that the first one is 1, then we have 2, 2, and 4. Let's see whether it is there or not. Go to stat, and again enter this first number 1, and you'll see the arranged data. Look at that. Is it arranged already?
Yes.
Okay, please copy that data in your note. Okay, I hope you copied the data. Now I'm going to go back to this example by stop sharing this one. So let me stop sharing it. So this is my arranged data. So we say that there were 13 observations. You can count whether I copied it right or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I copy it right? No, right? No, look like I didn't copy everything correctly. So let me erase and then write it down again. Help me with this. So the first one is 1, right? 1. Then we have 2, 2, 4, 6, 6.8, 7.2, 8, 8.3, 9, 10. And what is after that?
10.
Say that again.
10 again.
10 again. Then
Yes.
11.5.
11.5.
11.5. Is that it?
Yes.
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 Okay, now we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That is right. So if you go back to your steps and look at it, our first step is to arrange the data. We arrange the data. We take help of calculator for that. And then we found how many are the number of observations here. N is equal to 13. So total number of observation is 13. We are looking for the middle value. So if you think of 13, 13 can be written as 6, then 1, then 6. Is it 13? Look at that. 16 is 13 is same as 6 plus 1 plus 6. So 6 on this side, 6 on the other side, then you'll have 1 in the middle, right? So that 1 in the middle is the median. So we have odd number. So we need 6 first, 6 items first. Let's count that. 1, 2, 3, 4, 5, 6 on this side. 6 on the other side. 1, 2, 3, 4, 5, 6 on this side. What is here in the middle? Look at that. There is one number in the middle, right?
Yeah.
Do you see that? There is one number in the middle. So that number which is in the middle is the median. So median, which we write as MD, median is 7.2. Is that quite easy? Yes. Okay. Any question on that? Yes, no?
No.
No question. We'll go to next example then. Okay, here is the next example. Let's find out what is given. For the following set of data, we have to find the median. And let's look at these numbers. We have 684, then 764, then we have 656, 702, 856, 1133, 1132, 1303. Now, please arrange this data in ascending order using your calculator. I'm going to give you about 1 minute to do this. Okay, I hope you arrange the data and you should obtain something like this. If this is wrong, just let me know. Here is my arranged data: 656, 684, 702, 764, 856, 1132, and 1133, and finally 1303. Is that what you got?
Yes.
Okay. Make sure you do this using calculator. Learn how to use calculator. For the small data, definitely you can look at it and arrange. But when you have big set of data, you must know how to use calculator. So after we arrange the data, we find we look for the number of observations. How many observations are there? 1, 2, 3, 4, 5, 6, 7, 8. N equal to 8 this time, which is even number. Okay. And if you want to find the middle for this one, you'll have 4 on this side, 4 on this side, and you don't see anything in the middle, right? Yes or no?
Yes.
Okay, so we do this. We have 1, 2, 3, 4 on this side. 1, 2, 3, 4 on this side. Here is the median. Median should be in the middle of these two numbers. Okay, median should be in between 764 and 856. And you don't see anything over here. Do you have anything in the middle?
No.
No. So what you have to do is, in this case, the median is the average of these two numbers. Okay. So median is the average of those two numbers. So let's write that. MEDIAN, median is equal to, average means you add those two numbers, 764 plus 856, and divide that by 2. How much you'll get? Please do that in your calculator. It is 764.
10.
How much?
810.
Okay, it is 810. So that is the median, 810. So in this observation, because you have the even number of observations, you don't have that median here in the data set. So what we did is, it is the average of these two middle numbers. Okay, any question in that? Just say yes or no and we'll move forward.
No.
No.
Okay, great. Now we have the third measure of central tendency. It is called mode. Let's talk about this now. When we say mode, it is the another measure of center. Okay. The mode is the most
Mode is the
frequent.
most frequent.
I can hear back echo. Maybe your mic is not muted. Please check your mic if it is not muted. Okay. So another measure of central tendency is mode, and mode is the most frequent data value. So we look at the observation and we look for the number of times the data is repeating. So if a data is repeating many number of time and it has high frequency, that is called mode. And there can be more than one mode in some data set. Okay, if the highest frequency is 7 and the other observation also have 7, then we say that there are 2 modes. And in that case, we say that the data is bimodal. When I just say this, it may or may not make sense, but here is an example. Let's find out what is here in this example. Statistics exam scores for 17 students are as follows. We have to find the mode. So here are the scores of 17 students. You can see 53. Now, because we are looking at the mode, we look at the repetition. Are there any repetition? So first one is 53, no repetition. Then we have 59, it is repeated twice. Then we have 63 repeated twice. Then we have 72 repeated, I don't know how many times. Just count, 1, 2, 3, 4, 5. Then you have 76, 78, 81, 83, and here we have 84. 84 is repeating 3 times. 72 is repeating 5 times. 63, 2. 59, 2. All other, they are occurring just once. So when you look at these observations, these scores, these are the real scores of 17 students from last semester. Okay. Now, when you look at these data values, which number is repeating the most?
72.
72.
72 is repeating the most, right? That means the mode is 72. So for this data set, mode is equal to 72. That is the meaning of that. Mode is 72. If this 84 was also repeating 5 times, say for example, this 84 is also repeating 5 times, in that case, that will also be the mode. So in that case, you will have 2 modes, and we call it bimodal in that case. But this one, we only have one data point repeated most of the time, 5 times. So the mode is 72. Any question on mode?
No.
No? Okay, we'll move to next concept then. Okay, next we are studying is the mid-range. When I say mid-range is defined as the sum of the lowest and the highest values in the data set. And we divide that by 2. Or you can say it is the average of the highest and the lowest value. Mid-range, we write like this, MR for mid-range. And this is the formula. Mid-range is the lowest value plus highest value divided by 2. Now, if you look at the example here, here is the example on mid-range. So number of bank failure for the recent 5-year period is shown. And the numbers are here, 5, 35, 150, 160, and 70. We have to find the mid-range for this. So in order to find the mid-range, we need the lowest value and we need the highest value. So for this observation, tell me what is the lowest value? What is L equal to? What is the lowest value of all these? 5. Okay. And what is the highest value?
160.
160. Okay, 160 is the highest value. So your mid-range is the lowest value plus highest value divided by 2. Lowest value 5, highest
So
value 1.
82.5.
What is it?
82.5. I apologize.
Oh, you already did everything, right?
Yes.
2.5, super fast, which is great. Yeah, that is right. 82.5 is the mid-range. So it is quite easy to find the mid-range. Once you know the formula, it is lowest value plus highest value divided by 2. All you need to do is, whenever you see any formula, make sure you make a separate list of formula so that it is easily accessible for you when you're doing your homework, okay? Any question on mid-range?
No.
No? Okay.
No.
We have 5 minutes before this session ends. So what I'm going to do is I'm going to work on one more concept before the session ends, okay? Okay, next concept that we are exploring in this video or in this lecture is the range. But remember, from range, we are working on the measure of variation. When I say measure of variation or measure of spread, how widely the data is spread, that's what we'll be looking in variation. So the first is range. And in order to find the range, what we do is we find the difference between the highest value and the lowest value. In mid-range, we used to add those two and divide by 2. But in range, we find the difference between the highest value and the lowest value. We have the same example that we have done before, the same data, but here we are calculating the range. So we already know the highest value and the lowest value. The lowest value was 5 and the highest value was 160. Now what is the range? Now the range is the highest value minus the lowest value. Your highest value is 160, lowest value is 5. So this implies your range is, how much is 160 minus 5?
155.
155. So that is the range. Okay, range is 155. Always remember, range is the difference between the highest value and the lowest value. Okay,